Welcome all. Welcome to Digital Design and Computer Organization Lab tutorial. My name is Mamata, Assistant Professor, Department of CSE, AI&ML, Rajiv Institute of Technology, Hassan. Welcome to DDCO Lab tutorials. Before go to the first experiments, that is 4 variable logic expression, first we need to know about basic gates. Let's learn first how to implement basic gates, that is AND, OR, NOT, NAND, NOR, XOR gates. By using Capture Light Edition, click on Capture Light Edition software, go to File, New Project. Here we need to give user defined name. Here I am giving basic gates as name because here I am designing basic gate circuit. You can give as your experiment names. Click OK and then select create blank project. OK. After one blank sheet will open. On this sheet we need to design our logic circuits. Here we are designing first basic gates. So go to place and select part in order to select the different gates. Here we are giving IC numbers for certain basic gates, not directly basic gates name. So first we need to know the IC numbers for each logic gates. Let me show you IC numbers. In this table we are define the IC numbers for different gates. For NOT gate we are using 7404 IC. For 2 input AND gate we are using 7408 IC. 3 input AND gate we are using 7411. 2 input OR gate 7432. NAND gate 7400, NOR gate 7402, XOR gate 7486. In this experiments we are designing only 2 input AND, OR and XOR, NAND, NOR. So first select place, part. Here first give AND gate 7408 IC number for AND gate. OK. Place the IC in the blank sheet and right click end module in order to cancel the selected gate. Then go to place, part and give IC number for OR gate, that is 7432 EVAL. OK. Place on the blank sheet, end module. Then go to place, part and give IC number for NAND gate, that is 74. Two input NAND gate is 7400. Place on the blank sheet, place part and give IC number for NOR gate, that is 7402 EVAL. Place on blank sheet. Give IC number 74864 for XOR gate. Select. Click on the blank sheet. Here we give 2 inputs and 1 output. In our every truth table, 2 input. First we need to know the truth table for every gates. In these slides we are giving we are showing the truth table for a AND gate. In AND gate truth table, the output is high when only we give both inputs as high. In other conditions, the output is 0. This is the truth table for OR gate. In this case, the output is 0 only for in this truth table we are showing OR gate. In OR gate, output is 0 only when the both inputs are 0. In other conditions, the output is high. This truth table shows the XOR gate truth table. In this condition, the output is high only when we give the any one of the input is high. In other conditions, the output is low. This XOR gate also known as odd gate because the odd inputs gives the only input high. This truth table shows the NAND gate. In this NAND gate, the output is high. The output is low when we give the both inputs as high. In other conditions, the output is high. This truth table shows the NOR gate. This is the complement of NAND gate. In this gate, the output is high only when we give the both inputs as zeros. In other conditions, the output is zeros. Here we are using 4 combinations of in all the 2 input gates. We are using 4 combinations of inputs, and in the input here there are 2. First we give 2 consecutive zeros and then we give 2 consecutive ones. In input B, first we give 0 and then we give 1, and first we give 0 and then we give 1. Consider this 1 unit as a one-time instance time unit. First in input A, first we give 2 units of input. In B, we give 1 units of input. Let's design this input by giving digiclock. Go to place and part and select digiclock and place it on the screen. Here we use 2 inputs, so we place the digiclock it 2 times and cancel end module. For cancel, select end module by right clicking. In order to connect the input to the every basic gates, we need wire. So go to place and select wire on that. Click on the node of the input and take one big line for every gates. Give the same connection. Here we are connecting input A to every logic gates. While connection, let's connect the connection without any distraction. After every connections, right click on it and end the wire. After giving a input to every gates, next to give the B input to every logic gates. Connect B input to first XOR gate, then NOR, then connect the B input to the NAND gate. Every connection, be careful and see the node of the connections. The node indicates the connection between the input and output. if we missed these connections, the output will completely different and it shows error. After input given, for output we are giving another wire by from all the basic gates as shown in the picture, as shown in the video. Let's give the output for every basic gates. Here we are giving 4 combinations of inputs. In input here 2 units of time the output 0 is there, and 2 units of time output is 1. Input is 1. In B input only 1 instance of time consecutively the inputs are changing. So the same we can give in the circuit design by giving off time as 2 US and on time as okay, and click on the on time of A input, double click on the on time, it displays the properties. There you can change the units of time. Here let's change the off time of B input as 1 US. Okay. Then on time of B input is 1 US. Okay. In order to see in the truth table of every basic gates, we are giving the inputs like this. After input and output connections, we need to give the names, variables for every connections. For that, we go for place and select net alias and give different variable, different alphabets for every wire or every connection. Here I am giving A and B as a input, and C has a output for AND gate. Again select net alias and give the E as a output for a OR gate, D as a output for OR gate, and E for output for a NAND gate. It is F as output for NOR gate, and finally select net alias and give G as output for a XOR gate. These variables which helps to differentiate our output. We can check the every outputs easily by using these variables. In order to check the every connections, let's zoom the screen finally after every connections completed and see the nodes of each connections, it's correct or not, and see the inputs units. After every connections, let's just save the logic circuit. For simulation, we go to PSpice and there select new simulation and give name as a basic gates. Create one new folder for simulation. Here below the some pop-up window is open that and give runtime as a 20 US. And give step size clear. In order to view the output clearly, we give the step size as 1 US or 2 US. It shows the output clearly in the waveform. Maximum step size 1 US. Apply and OK. Then PSpice run for simulation. Simulation window is open below. Open that window, pop-up window. Here the blank screen is opened. In order to select the input and output, after that only waveform we will get. In order to select that variables, go to trace. In the trace, select the variable what we are given in the logic circuits, that is A, B, C, D and E, F, G. Okay, the output is as shown in the figure. If you get confused for in order to check the every output in one single waveform, let's split into every gates. ABC, select ABC. It shows the only for output for AND gate. In order to check only for OR gate, what we give for OR gate output variable, that is D. When we select, go to the trace and select ABD variables, it shows output for AND gate. AB as input and C is the output for AND gate. If we select D, it gives at trace. If we select A, B and D, it gives the output for OR gate. Here in the waveform, OR gate output is when both inputs are 0, output is 0. Here the output, when we give input 0 and 1 condition, the output is 1. Like this, we can check the output for every single gate by giving the correct output variable what we have given in the circuit design. This is the output for the NAND gate, and select the A, B and E is over. F output for NOR gate. After selecting the variables, run the simulation window. It gives the output. In this, check the truth table is verified or not by seeing the waveform. Like this, we are going to design the different logic circuit. In the same manner, we are going to design the different logic circuits. That is, experiment 1 and experiment 2 is doing the same thing as shown, as we done in the basic gates.